Review sheet H. We're asked to find in A part 1 the value of the investment, so we're going to use this equation that we're given at the top. It says initially is telling us right at the start, so t equals 0 is the substitution we make in. So we end up with v equals e to the minus 0, 1 plus 3 times 0 plus 3, 0 squared, 0 to the power of 3. E to the 0 is 1. Everything in this bracket gives us 1. So the value of the investment, 1 times 1, equaling 1. V is given in thousands of pounds, so our answer is the initial investment is £1,000. In the second part, it wants to know after 1 month. So this time the substitution we're making is t equals 1. Put it in exactly the same way. And use your calculator to find the answer. The answer you get then is 2.943. Remember again, that's in thousands of pounds, so the answer is 2,943. Part B is a show that question, and we need our initial formula. I'm going to differentiate V using the product rule. So this part here will be my u, e to the minus t, and if I differentiate that, I'll end up with minus e to the minus t. Remember, the number in front of the t moves down to the front, and that's like having a minus 1 in front of it. So I've got minus at the front. This second part then is my v. If we differentiate that, the 1's going to disappear. 3 plus 6t plus 3t squared. So now using the product rule, u dv dx plus v du dx, I'll get dv dt equals u dv dx. Remember, keep in brackets. That's from there. Plus v du dx. So I'm just going to rearrange that. I'm going to leave this first part the same. And then with this second one, I'm going to bring this term to the front. So I'm going to have minus e to the minus t times by 1 plus 3t plus 3t squared plus t cubed, just copied from above. Looking at this now, I can see I've got e to the minus t in both of these terms. So I'm going to take that out as a factor, e to the minus t. So from this first term then, I'm left with 3 plus 6t plus 3t squared. From the second term, I'm left with this. But remember, we've got this minus sign here, which will be multiplied by each of those. So I'll be left with minus 1 minus 3t minus 3t squared minus t cubed. On this next line then, I'm going to simplify this bracket just here. So dv dt equals e to the minus t. I've got 3, take away 1, so 2. Looking at the t terms, I've got plus 6t here, take away 3t, so plus 3t. Squared terms cancel each other out because I've got plus 3t there, minus 3t there, and so I've just left with this minus t cubed at the end, which is what you had to show. For part C, we use the result we've just found in B, and we substitute in t equals 2. So here's dv dt as it was shown in the question, and all we're going to do now is to substitute in this value of t, giving us dv dt equals e to the minus 2, 2 plus 3 times 2, minus 2 cubed. Because it's a show that question, make sure you include lots of detail. E to the minus 2 is 2 plus 6 minus 8. E to the minus 2, 2 plus 6 is 8, take away 8 is 0. There we've shown dv dt is 0. To find the second derivative, we need to use dv dt from the previous part. Using the product rule, u will differentiate to minus e to the minus t. My v part here will differentiate to 3 minus 3 t squared. So dv dt is e to the minus t times by 3 minus 3t squared plus second part 2 plus 3t minus, that should be minus t cubed minus t cubed times by minus e to the minus t. So I'm just going to switch this second term around as I did before to make it easier to see where we're taking the factor from. So I'm bringing the minus e to the minus t up front and leaving this in brackets still. Okay, now from these two terms, this one and this one, I'm going to take out e to the minus t as a factor. So here I'll be left with 3 minus 3t squared, and over here minus 2 minus 3t plus t cubed. The sign's changing because of this sign here. Tidying up what's inside the bracket. Got 3 take away 2 to give me 1 t squared. If I do the t terms next, I've got minus 3t here. T squared terms, minus 3t squared, and the t cubed term. So there's my answer for d squared b dt squared. To determine whether at t equals 2 we have a maximum or minimum stationary point, I'm going to use the answer to the last part of the question. And we're just going to substitute in t equals 2. So I'll have e to the minus 2, open bracket 1, take away 3 times 2, minus 3 times 2 squared, plus 2 cubed. Putting this in my calculator, I get an answer of minus 1.218. We're interested in the fact that it's a negative, because a negative value here tells us that we have a maximum point. Part F wants me to find the maximum investment predicted by the model. So I'm going to use t equals 2 and replace that in the initial equation that we were given at the start. Substituting in the value t equals 2, so e to the minus 2, 1 plus 3 times 2 plus 3, 2 squared plus 2 cubed. And putting that into my calculator, remember this answer is in thousands of pounds, so the actual investment is 3654. In order to sketch the graph, you can use a table function on your calculator in steps of 1, going through from t equals 0 to t equals 12. You can then plot these on the graph paper. This is the shape that you should come out with. We've got our maximum point here when t is 2 that we were expecting. Initial investment of 1,000, so the one here which we found earlier in the question. We've got an area where it's rising here and then falling off.